This is a key to worksheet number 7 on radicals, and on this worksheet you're dividing radicals. So basically, if you look at this, you have in your denominators in all of these, there are two terms, and one of the terms contains a radical. In this case, we're dealing with square roots. And so basically what you're going to do is you're going to rationalize the denominator. Now, to rationalize these denominators, you're going to have to use the conjugate. And so in the process, we're going to talk about the conjugate with each of these problems. Okay, so let's look at number 1. In number 1, we have 36 divided by the square root of 7 minus 1. Now, to get this denominator to be a rational number, see, the square root of 7 makes this denominator an irrational number, which really makes the rational expression, this expression a irrational number. But basically, we just want to make sure that there's no square root in the denominator. It's okay to have a square root in the numerator, but we don't want, in math, we normally don't want the denominator to have a square root. So since there are two terms, we're going to use the conjugate. Now remember, the conjugate, I'm using the word conjugate, the conjugate of square root of 7 minus 1, basically all you do is just take this middle sign and you just change it. So you're going to multiply, and I'm going to go ahead and rewrite this over. So basically you're going to multiply both numerator and denominator by the conjugate. Okay? All right, now remember that this expression is equivalent to this expression because this right here is 1. So this times 1 is itself. So you're just going to rewrite this in a different way to where that denominator is no longer has a square root. Now remember, when we in one of our lessons when we talked about multiplying conjugates with square roots, remember the outer and the inner. So if you think about that, so I'm going ahead and multiply the two binomials out that's in the denominator. So when I FOIL this, I want you to notice about the outer and the inner. Look at the outer and the inner. The outer is square root of 7, because square root of 7 times 1 is square root of 7. The inner is negative square root of 7, and when you add them up, you get 0. In every case, when you multiply a radical expression that has two terms by its conjugate, the outer and the inner will add up to be 0. So basically all you're looking at is, in terms of FOIL, is the first. So square root of 7 to square root of 7 is the square root of 49, which is 7, right? So this becomes 7 right here, square root of 49. And then the last is negative 1 times a positive 1 is a negative 1, and so this is 6. So the denominator is now 6, because the outer and the inner will always have to be 0. As long as those are conjugates now, those have to be conjugates for this to be true. Okay, so now let's look at the numerator. All right, so in the numerator, look at what you have. Your numerator here is a monomial factor. Your numerator here is a binomial factor, so you're going to distribute. So basically what you have is this. You have 36 times square root of 7 plus 1. Okay. Now before I distribute, I want you to notice I can reduce. So always look for that. Always look and see if you can make this expression simpler. Okay. So I can reduce here. So 6 into 6 is 1. 6 into 36 is 6. And then distribute. So when I distribute, I get 6 square root of 7 plus 6. And that's the answer. All right. So that's the answer number 1. So number 1, you have 6 square root of 7 plus 6. So 6 square root of 7 plus 6. All right, number 2. Number 2, we have this. Number 2, we have 3 divided by 4 plus the square root of 5. All right, and so notice that in the denominator, I have a binomial that in which one of its terms, and it can be both, but at least one of its terms is a square root. So to get rid of this square root right here, I'm going to have to multiply, and let me go ahead and rewrite this over. I'm going to have to multiply both numerator and denominator by the conjugate of the denominator. That is the only way that this square root will no longer be there. And so when I do that, I get 4 minus the square root of 5, 4 minus the square root of 5. So the conjugate of 4 plus the square root of 5 is 4 minus the square root of 5. You just change that middle sign. Okay? Now, we're going to go ahead and multiply this out. So let me just remind you what's going to happen. 4 plus the square root of 5 times 4 minus the square root of 5. So remember, the outer and the inner will always be 0, and that's true because, look, the outer is positive times negative is a negative. Negative 4 square root of 5. The inner is a positive 4 square root of 5, and you get 0. So basically, all you have left is in terms of FOIL is first, 4 times 4 is 16, and then the last, a positive square root of 5 times a negative square root of 5 is a negative square root of 25. Square root of 5 and square root of 5 is square root of 25, which becomes 16 minus 5, which is 11. So my denominator is 11. So remember, the direction says to rationalize the denominator, right? So basically what I've done is I went from an irrational number to a rational number. I went from an irrational number to a rational number. Rational number being 6 in this case. Rational number being 11 in this case. And now this is a monomial times a binomial, just like we had up here. So you're going to rewrite this as 3 times 4 minus the square root of 5. Now let's just check and see if you can simplify anything here, reduce anything. And 3 and 11 I cannot reduce, so then I'm just going ahead and distribute. And so I'm going to get 12. 3 times 4 is 12. Minus, and then 3 times the square root of 5 is 3 square root of 5 divided by 11. And so there's your answer there. Okay, so number 2, the answer is 12 minus 3 square root of 5 divided by 11. So 12 minus 3 square root of 5 divided by 11. Okay, number 3, let's see what we have in number 3. So number 3, we have 8 divided by 8 plus the square root of x. All right, and so notice I have a square root in the denominator, so we need to get rid of that square root. So we're going to have to multiply both numerator and denominator by the conjugate of this denominator. So the conjugate of 8 plus the square root of x is 8 minus the square root of x. But what I do to the denominator, I do to the numerator. So this is the same as this. Notice these two are equivalent because this right here is 1, and 1 times this is still this. But the way it looks is going to change, though, because when I multiply this out, obviously, see, this looks different than this, but they're equivalent. This is the same as this with a denominator of 11. All right? This right here is equivalent to all of these, but in particular to this with a denominator of 1. All right, so those are the same. They're equal to each other. They just look different. All right, it's just kind of like saying 6 is 12 over 2, right? I mean, they're equal to each other. They just look different. I wrote 6 as 12 over 2. It's a different way to write 6, and that's what's happening here. Okay, so now let's go ahead and multiply the denominators. And those are conjugates, right? So if there are conjugates, remember, 2 binomials, you're going to use a FOIL method. Since those are conjugates, the outer and inner should be 0. All right, so let's see what we get. 8 plus the square root of x times 8 minus the square root of x. So the outer, 8 times the negative square root of x is negative 8 square root of x. The inner, a positive square root of x times 8 is a positive square root of x. And when I do add them up, I do get 0. 8 and the 8 square root of x and negative 8 square root of x is 0. So really all I have left is the first, 8 times 8, 64. A positive times a negative is a negative. Notice that when you multiply 2 conjugates, the last is always going to be a negative sign. Positive times negative, so the signs are different. And then I want you to notice the square root of x times the square root of x is the square root of x squared. But remember, what's the square root of x squared equal to? It's equal to x. So the denominator is 64 minus x. So it's that subtraction, is that binomial 64 minus x. But notice I no longer have a square root. All right? Now, let's look at the numerator. The numerator, I have a monomial times a binomial. So I have 8 times 8 minus square root of x. Now, don't make the mistake and reduce and simplify the 8 into 64. You know that 64 is not a factor in the denominator. It's part of this factor here. because of the subtraction. So you got to be careful. That's not true. All right, it's kind of like saying if you had, I'm gonna go ahead and say that here. It's kind of like saying if you had 3 divided by 3 plus 5. You know you can't do this. That's wrong, right? Because this is not 1 over 1 plus 5 is 6. And if you think about it, when you do this, when you add this denominator, you get 3 divided by 8, and that's not the same thing. So you cannot do that. 3 is not a factor of this denominator because of that addition symbol. Remember, factors are separated by products. So that's not 3 times 5. If you had this, then you could do that. That's true because that's a factor. That's multiplication right here. So some of you still have a little bit of problem with that. Most of you got it. Most of you know what to do with this. But there's still a few of you that still seem to think that you can reduce these, and you cannot. You cannot. Okay? But what I'm going to do now is go ahead and distribute, just like I did with the previous ones. So I get 8 times 8, 64, minus, and then 8 square root of x, all divided by 64 minus x. And so that's the answer there. So in number 3, I get 64 minus 8 square root of x divided by 64 minus x. All right, number 4, let's see what we get at number 4. So number 4, we have square root of 2 divided by the square root of 3 plus 8. So again, I have a square root in the denominator. It's okay to have a square root in the numerator. Remember, the direction says to rationalize the denominator. So make the denominator a expression that doesn't have a square root. All right, so in this case, since those are real numbers, basically you're making the denominator a rational number instead of an irrational number. So let me go ahead and write this over so that way I can use the idea of equivalent expressions. All right, so to get rid of this square root, I'm going to multiply both numerator and denominator by the conjugate of this. So the conjugate of square root of 3 plus 8 is the square root of 3 minus 8. You just change the sign. But what I do to the numerator, remember this is still considered the expression 1, so both of these have to be the same. All right, and then let's go ahead and FOIL the denominator out. So if you think about what we have the square root of 3 plus 8 times the square root of 3 minus 8. And then if I look at the outer and the inner, remember the outer and inner should be 0. So square root of 3 times a negative 8 is negative 8 square root of 3. A positive 8 times a positive square root of 3 is positive 8 square root of 3. And notice I do get 0. And so basically all you're going to have is looking at the first and the last of FOIL. So the first, a square root of 3 times square root of 3 is a square root of 9. A positive times a negative is a negative, and then 8 times 8 is 64. So this becomes square root of 9, which is 3, and 3 minus 64 is a negative 61. So that's the denominator. And so notice that negative 61 is a rational number. Now the numerator, I have a monomial times a binomial. So let me go ahead and rewrite it like this. Square root of 2 times square root of 3 minus 8. Okay. Now let's go ahead and distribute. Okay, when I distribute, I get the square root of 2. Look at what you have. Square root of 2 times the square root of 3. So according to the product rule for square roots, I can write this as 1 square root by multiplying the radicands together. 2 times 3 is 6. So this is the same as this. So I get the square root of 6 minus, and then square root of 2 times 8. Always write the radical last. Always write the square root at the end. Divided by negative 61. And so there's your answer. Now another way you can write this, and you got to be careful though, another way you can write this is to put, see this negative, since that's just one factor in the denominator, you can put this negative out in front of the whole thing. So in other words, you can do this. Square root of 6 minus 8 square root of 2 divided by 61, where this whole thing, you're going to say the negative of this or the opposite of this. All right. And the other thing you can do, what I've noticed that some students did was they didn't want the negative in the denominator, so they just went ahead and distributed it to the numerator. You got to be careful though. You got to change all these signs. So basically, you're saying you're going to make the denominator positive 61. So you're going to take this negative 1. See that's really negative 61. If you think about it, is really negative 1 times 61. So you're going to rewrite that negative 61 in the numerator, multiply the numerator by it. So you get negative square root of 6 plus 8 square root of 2. All right, so that's the same thing as this, and then that's how we got this. Okay, so these are 3 different ways. The majority of students, though, left it like this, and that's fine. A few prefer to write it like this. Maybe one person did this, but it's sometimes dangerous to rewrite it like this, where the denominator is negative, because many times students kind of mess this up right here. So to be on the safe side, just leave it like this. You're fine. Leave it like that. Nothing wrong with this. That's the way I would have left it. Either that or this, but that's fine. All right, so that's number 4. So number 4, I'm going to write the answer as the square root of 6 minus 8 square root of 2 divided by negative 61. And then finally, if you look at number 5, you have 2 radicals in the denominator, 2 square roots. So let's see how that looks. So this is number 5. And so number 5, we get okay, so number 5, we have 5 divided by the square root of 6 minus the square root of 11. So again, I still have a square root in the denominator. In fact, I have 2 of them. So, and then this square root of 6 is irrational. The square root of 11 is irrational. So this denominator is irrational. I just want to make this a rational number. I want to rewrite it so that there are no longer any square roots in the denominator. So what I'm going to do is I'm going to multiply the original problem, which is this, times the conjugate of the denominator. So the conjugate of square root of 6 minus square root of 11 is the square root of 6 plus the square root of 11. But what I do to the denominator, I've got to do to the numerator, because remember, this is equivalent to this. So meaning that this right here needs to be 1. So that expression divided by itself. So 1 times this is still this. But now it's going to change what it looks like, though. This is going to look different. But it's still the same, it's still equivalent. Okay, the denominator, let's go ahead and see what that looks like. I have the square root of 6 minus the square root of 11 times the square root of 6 plus the square root of 11. All right, so it kind of reminds you of, if you think about all the 4 we just did, it kind of reminds you of the difference of 2 squares. I mean, when you factor the difference of 2 squares, that's what it looked like, right? And so when you multiplied the difference of 2 squares, the outer and the inner added up to be 0. Same idea. Difference of 2 squares added up to be 0. Difference of 2 squares when it added to be 0. So remember when you did that, when you factored polynomials, that was the difference of 2 squares? It's the same idea. So the first terms are the same, the last terms are opposite of each other. So just like when you factor the difference of 2 squares, the outer and the inner add up to be 0. So now be careful here. The square root of 6 times the square root of 11. So remember, this is what we have. The square root of 6 times the square root of 11. So according to the product rule for square roots, I can write this as the square root of one square root, and just by multiplying the radicand. So 6 times 11 is 66. So the outer is square root of 66. The inner, a negative square root of 11 times square root of 6 is negative square root of 66, and they add up to be 0. So really, again, all we have is first and last. So let's think about this. The square root of 6 times the square root of 6 is the square root of 36, which is just 6. So I get 6. A negative times a positive is a negative, so the last. Same thing. Square root of 11 times the square root of 11 is the square root of 121, which is 11. So I get 6 minus 11. So 6 minus 11 gives me negative 5, right? So that's going to be my denominator, negative 5. Okay, now the numerator, I have a monomial times this binomial here. So I get 5 times the square root of 6 plus the square root of 11. Now before I distribute, remember, let's try and reduce if we can. And we can here. 5 into 5 is 1. 5 into negative 5 is negative 1. And so then I get the 1 times the numerator is the square root of 6 plus the square root of 11 divided by, and the denominator is negative 1. Okay? Now, normally, I'm going to say this. Normally, if the denominator is 1 and negative 1, you want to rewrite this. But many students have a little issue with a negative 1 and not knowing what to do with something that looks like this. So if for some reason you left it like this, I would give you full credit. But this is what we want you to do, though. we want you to think about what this says. So this remember, it's kind of like if you had something like this. Like if it had 4 plus 6 divided by negative 1. So do y'all agree that 4 plus 6 divided by negative 1 means 4 divided by negative 1 plus 6 divided by negative 1? Okay? And then 4 divided by negative 1 is a negative 4, and then 6 divided by negative 1 is a negative 6. So basically notice what happened. So when you divide by negative 1, all the signs in the numerator, if you rewrite it to where you just have 1 in the denominator, see 4 divided by negative 1 means the same thing as negative 4 divided by 1, right? 6 divided by negative 1 means the same thing as negative 6 divided by 1. So basically, what you're doing is you're taking all these terms in the numerator and dividing by negative 1. And you get this, which is negative 4 minus 6, which becomes negative 10. Same thing here. So what I want you to do is to take each term and divide by negative 1. So the square root of 6 divided by negative 1, negative square root of 6. The square root of 11 divided by negative 1, negative square root of 11. And that's it. Now, you see how I was able to combine like terms here? Because those are like terms. These are not like terms, remember. Like terms with square roots, they have to have the same radicand. So same index, they do. Square root, index 2. But the radicands are different. So there's your answer right here. Okay? So the answer number 5 is negative square root of 6 minus the square root of 11. And that's the answer. So that's the key to worksheet number 7.